Okay, YouTube, in this video we're going to continue to look at inverse functions in their graphs. So let's consider this example here. It says find the inverse of the function f of x equals x squared minus 2, where x is some positive number, and then graph the function and its inverse. So let's go ahead and start with finding the inverse. And so we have this function here, y equals x squared minus 2. In order to find the inverse, the very first thing we typically do is switch the domain and range. And so we accomplish this by switching x and y around. Let's go ahead and add 2 to both sides here. What we're going to accomplish is isolating the y value here. So we say y squared, and then we're going to take the square root of both sides. And so what I'm going to say is this. Just to keep this as being a function, what I'm going to say is instead of plus or minus the square root of x plus 2, I'm just going to write it thusly. And so we finally end up with f inverse of x. And f inverse of x is equal to the square root of x plus 2. And I'm going to put a box around this. This is our inverse function right here. And so we would say that this is very, very true. But because we switched the domain and range on the function, we saw that with the original function, this is really the domain right here. And so they're saying that all x values must be greater than or equal to 0. What I'm going to write down here is that all y values must be greater than or equal to 0 would be the range of this function here, because this is the domain of the original, and the domain and range kind of switch roles here. And so when we look at graphing these functions here, let's go and start with the original function. This is, I recognize, just the quadratic parent function shifted down 2. And so I'm going to go down 2, I'm going to draw a dot, and I notice that the definition here says this only exists for positive x values. So I'm going to say that, you know, my quadratic parent function goes 1, 1, and we go over 2 up 4 from the original height here, which is at a height of -2. So kind of this here, we would see that we get this parabola or paraboloid because we could put in the left side of this graph here. But what I'm going to say is because of this definition here that says x values can only be positive, I'm going to say it's really only that right there. And so with respect to graphing this, we're going to go ahead and call this what it is, f of x. Let's go ahead and graph f inverse of x. Now, looking at f inverse of x, we notice here that this is the square root graph, but it's been shifted left 2. So we're going to go left 2 from the origin, okay? And the a value out in front here is a 1. So we would say there is no vertical stretch, so we're going to go up 1, right 1. And then usually we'd go right 4, up 2, which is this point right here. We could see that this graph kind of loops around right here. And then its range is all y values greater than or equal to 0. But we're going to label this as f inverse of x. And so we could clearly see that these are inverses, and I say clearly because they are reflected about this line y equals x, first of all, and second of all, because we can see that all the domain and range have switched for both of these graphs here. Cheers.